In this video, let's add in some collision objects so that our fire can wrap around these logs. I'm going to start by creating a static object, like that. And as we go here, let's also turn off this little brain down here so that we're not thinking about things as we go. I'm going to call this our logs collision, like that. And if you set a merge right here, we can control the relationship between the static object and the smoke object up here. So I'm going to bring this logs above the pyro solver, and then I'll say left inputs affect right inputs. So this static object is affecting the smoke object. And so now that is the correct setup for that. So with this static object, with this collision, I think it makes the most sense to create some sort of VDB volume-based collision so that the smoke object can see that and it bounces off. Usually whenever I make collisions, that's the route I go. So let's go back to the object level and go back to our pyro source to create those collision volumes. Starting with the fire pit, let's go here. We need to bring over this transform, so let's right mouse here and say actions, create a reference copy so that this node is always the same thing as this node. And this will scale things up to where we're at and bring it to the origin, which is just fine. Now all we need to do is get rid of everything we don't need. So S for select, and I'm going to go here to that select by group, cogwheel, 3D connectivity, and then we should be able to just select everything except for the main basin. And we could probably get rid of decals like this. You know, just anything that's really not necessary. We can remove that and not waste voxels on it. Sometimes when selecting things with a tablet, it's a little bit difficult to do that. But there we go. We got that and we got that. And just be sure that we don't have any extras, and we can just press delete. So that now we just have the main basin right here. Create a VDB from polygon, and we want to get away with the most coarse resolution possible. So let's try 0.05 and go down from there. If we hold down middle mouse, we can slowly begin bringing this in. 0.01 might be our best bet. For right now, let's create a null, and we will call this our fire pit. Well, let's do all caps. Fire pit colliz out, right there. Let's now go back to dops and add this into our static object. So we'll go here, there's the static object, drag this over to our saw path, and then go down to collisions, down at the very bottom, under this proxy volume, drag that right there. Now, if we check on this collision guide, and we say mode, volume sample, this ought to show us what this is doing. And the reason why we don't see anything is because we need to turn this brain on down here. That tells Houdini that we can think about simulating stuff. Check off this display geometry right there, and now we actually see the collision mesh that's being used to calculate all these volume collisions. And I really don't mind that we don't have the resolution here on these rings. As a matter of fact, I'm going to include that with this blast. So let's go over here again and just add that in to the things that we don't really care about. Okay, so we have that. Again, back to our static object. We now have this, and we might be able to get away with a little bit more of a coarse resolution, but it's a little bit doubtful. Going back and forth, you'll notice that we're starting to lose the resolution a little bit too much. So let's leave this at 0.01, say that's just fine. And then I'm going to create another static object for the logs. And the reason why I like separating out two static objects like this is that I want a really fine control over the resolution of each thing. So for instance, on the logs, we could probably get away with being more coarse than we can with this fire pit. And so because of that, it makes sense to have two static objects which control two different collision resolutions, if that makes sense. So let's go to our logs and do the same thing. After the transform here, we'll just say VDB from polygons, plug that in. And I believe this should also contain the embers, which is not ideal. So let's get rid of those embers by creating a group for them. We'll say group. We'll call this group node embers underscore group. The group name will be $OS. That means take the node name, embers group, and that's the group name. Base group is going to be everything because this is just the embers. And now create a copy of that node, Alt, left mouse drag, hold down Y to cut there, and we will call this our logs underscore group. Now that we have two groups, I can simply say VDB from polygons. Before that happens, get rid of the embers. That's by using a blast node right there. And I could say this will be our embers group. So that now we have just the logs and we're good. Let's create another null right here. And we'll call this our logs colliz out. And we'll just kind of organize this a tad bit. So we'll go like that. And do all that sort of business. Now that we have this, let's go to the other static object. And let's call this one our, well, hold on. Over here, this is where we had the fire pit. So we'll call this our fire pits colliz right there. And then this guy will be our logs colliz. Let's create another merge in dops. And we're going to merge these two static objects together. The reason why I have a different merge right here is that I want to control the behavior between these two static objects. And I just want to say that there is no relationship between the two. I don't want the solver thinking about how the logs collide with the fire pit because that's not necessary. So with that in mind, we have the setup that looks like this, and that's good. Now in the logs collision, all we need to do is bring over these nulls. So the SOP path will be right there. Down at the proxy volume, we'll do that. And now that we have all this, let's check the fidelity of this. And we want enough resolution to maintain the holes between the logs. So we'll do the same thing here, 0.01, see where that gets us to start. And that's not half bad. We could probably get away with a tad bit more than that though. So let's try 0.015, maybe even 0.0175. And we just go up gradually until we have too much, or until the resolution is too coarse. So I would say 0.0175 seems to be a pretty decent resolution for this. Let's uncheck this collision guide, turn back on display geometry. Once you have both static objects in place, double check these merges. Right here, we need to make sure that this happens before the pyrosolver hits it. So we needed to switch those two wires because left affects right there. Once you fix that, if we now go back to where we were in SOPs, I want to demonstrate an issue that you are likely to run into. Also create this little section right here. We'll call this our colliz volumes. There we go. And we'll just kind of put that off to the side a little bit. Okay, so here's the issue. We're sourcing in these flame volumes, right? So that's down here. We have all these flame volumes going on. Well, that's all good and stuff, except for the fact that the static object collision mesh overlaps with where the sourced in volume is. And because they are both sitting right on the surface, this collision mesh is going to be choking out a lot of the volume that we have sourcing in with this pyro source. So let me show you what I mean in practice. Let's go to DOPS, and I'm going to go forward a few frames. What you'll notice is that now we have the flames being much, much shorter. This is what it was before. This is where it is now that we have those static objects in place. And in general, this is a good thing. However, I just want to point out that a lot of the volumes that we sourced in are being cut off because of these static objects. So in the Pyro source, what I'll do is I'll go here, and before we scatter all this, so this is right after the attrib paint, let's go ahead and use a peak node. And this will just push everything along its normal. So if we go out a little bit in this distance, like let's say 0.01, this is before, this is after. You'll notice how everything just sort of inflated a little bit. And this is good not only for playing nicely with the static objects, but this also helps out in giving us that effect where the flames are offset from the surface a little bit. So it's a good thing in multiple ways. Now that we have a bit of that padding going outwards, let's recache this Pyro source and see what that gives us in DOPS. Once we do a flipbook, as you can see, now we have the best of both worlds. We're not choking out those flames anymore because we added in that extra padding through SOPs. And at the same time, we have those collisions. We're now colliding with the logs, the flames are wrapping around them, and things are looking generally pretty good for what they are. In the next video, let's talk about shaping these flames with various different microsolvers, sourcing methods, and what we find on the sparse Pyro solver itself.